G'day. Today I'm building a new tool which will hopefully help me measure diameters, particularly in a situation I'll get to in a moment. I've got several ways of measuring diameters here in the workshop, and I'll show you a few of those, but this is something that I've been trying to work out probably for 4 or 5 years now, so it's a long time coming. I'm a bit time poor at the moment, so I haven't finished. Sorry about that. I'd like to be able to get things done in an episode, but sometimes it doesn't happen, and there are lots of parts in this one. The diameters I'm talking about measuring are internal diameters. External diameters are easy, just use a micrometer for those, and that's not a problem. But measuring internal diameters accurately, so that you can achieve a good fit on them, can be tricky. Usually I want to measure a diameter like that so I can get a close fitting shaft in there, and so I want to measure better than 0.1 of a millimeter, and that's the problem. I can use something like these, but the uncertainty on these is something like 0.05 of a millimeter, so it's probably not quite good enough. And I also find that if you're not careful and you put too much force on them, you can get a false reading. Okay, so this is a 25 millimeter ring gauge, minus 9 microns, so it's 24.991, but I'm getting 2501 there, so maybe not such a wonderful way of doing things. Recent addition to the shop are these things. These are 3-point micrometers, ball micrometers, intramix, the whole variety of name for them. Hole test is if it's a Meditoya. That's saying that is 0.04 of a millimeter underneath 25, but you can see there's a little bit of wobble there, so I can probably do that again, get a little bit better. But that's improved me about 0.01, but that's another way I've got, but that's only a recent thing. Once upon a time I used to try and use these things. Trouble is with these, even using the appropriate wiping technique and doing that, I could usually only get to within, see, that's 24.92. I couldn't get the accuracy out of these that I wanted. Then I got one of these, and I bought this second hand a number of years ago. This is an Interapid IRA 2A. They come both in imperial but also in metric. And the way these things work is you put the thing you want to measure there down, and you wind out until you get the needle on the graduation. Then you can come along with a micrometer and measure that. Sit. And basically you do your micrometer until the needle goes back to 0 again. And that's saying 25 on the dot, which is about what it should be. So this is extremely accurate. It goes from 3/8 of an inch up to 6 inches, or 9.5 up to 152 millimeters. Really nice. However, there is one drawback to it, and that is if you're boring something on the lathe, or even boring something with a boring head, you've got to have the clearance to get it in. And so this build is basically a homemade version of this, but with pins coming out of the bottom so that I can sneak it in and measure that way. The two legs that I'm making are basically mirror image, so what I'm doing to conserve material is I've got them nested inside each other, and then I've put a slice in here with the angle grinder, and then I'm coming along and chain drilling through. But you can see that I'm going to run into trouble very soon because there'll be nothing holding these two things apart. So what I'm going to do, if I'd thought about this before I started doing it, I could have put it on a couple of blocks here, clamped it down so there's no crushing pressure that way. I could have also done the drilling without putting these cuts in here, then come along and put the cuts. But what I'm going to do here is just take this out and use an angle grinder to do that final bit there. So just a trap that I nearly fell into. Yeah, when you've got stuff in a vise, just be careful how you take material out. Once I've got these out, I'll then just sort of smooth them up, and they're roughly an L shape, as you'll see. These are the two legs that I need. This is just the machine part. I need to put a bracket on here for them to pivot on. The reason that they are offset like that is there's a bit of stuff that goes in the middle there, so that's necessary. Otherwise they would have been straight. At one stage I was contemplating making those out of key steel, but then a friend of mine said, "Oh, you should do them out of stainless." Yeah. Stainless is one of those things that I mean, it does what it's meant to do, but it's also a pain to machine at times. So I need to weld some brackets on and then make up a few little bits and pieces that go in the middle. These come with there are a couple of holes in there. If this was a proven design, I'd put the holes in, put a pin in there, and use that to machine these. As it was, I just clamped them together and then clamped them in the vise and machined off these surfaces. But you know, that was purely because I don't know exactly where those holes are going to be or what they have to do. So it's another one of these feel your way sort of projects. Sadly, I've designed this tool needing a couple of linkages. They're a funny looking thing, and I mean, I guess if this was a production tool, you'd make up a press tool and stamp that out. As it is, I'm going to have to just fabricate them. What I've done is I've drilled the end holes in the 4 linkages. I'm now going to bolt those together with an M3 bolt, so it's a close fitting hole, M3 bolt, and then drill the other end, and that way at least I'll get the holes in the linkages the right length. What I'm then going to have to do is make up a spacer so that when I weld these 2 linkages the right distance apart, the spacer will enable that and allow me to get these 2 holes in the right spot, rather than having, you know, effectively one hole there and one hole there, or whatever the story is. On these long legs, I want to put a little U-shaped bracket. So what I've done is I've bent up a bit of strip, just welded it on there, and then I'm going to fold that over when I've got a block the right height to get my you know, the right gap in there. I'll put a hole before I do that, and then I can just drill straight through into that one and try and get those holes lined up. On these things, they are meant to be sort of 2 parallel bits like that with that in between. 2 ways of doing that. One is I could make up basically what's an L-shaped block with a couple of tapped holes. I could secure those either side, put my plate in the middle there, and weld away. Instead, what I'm doing is I've got a block, not steel, because the stainless will weld to steel quite readily, so it's copper, I think. I've got a number of copper and aluminium blocks around the place, which I use for that reason. Holding that there, weld that up, and then what I'm going to do is get a couple of spacers like that, and then weld that up, and that'll give me the precise spacing I want in there. And give me that you know, bracket that I'm after. I bent this down. That's the block that's going to be turned into a part that sits in there. And confession, I was using a blunt cutter on this, and so it's a little bit undersized, about 0.15, 0.2 than I'd like. So just as well I did it this way. So the way I did it was basically clamped that in there. I have a spacer piece here, which is the same material, just there. Clamp that in the vise, and then with the hammer just knock that over, and that's enough to form that. I won't bother drilling the hole in there and trimming those to length and all that sort of thing until later. That's when I have some other holes to drill in here, but for the moment, just to get those done is good, because it means I can then machine this block down to the size I want that. I want to turn effectively a spigot on the end of there, 25 millimeters long, diameter 8, 10, something like that. I'll need to check the drawing, see what that says. So I squared this up in a, or sorry, centered this up in a 4-jaw chuck. I've had to use my little jigger thing so it doesn't slip down the hole in the chuck drawers. When doing this, and this is the reason I'm saying this is because I did this once, is that if you're doing square stock, it's not such of a problem. But once upon a time I was centering up some rectangular stock like this, and I just pulled the lever back to go around to the next side, and then I wiped out the end of my indicator. So that's something to watch for. If you have to do this, don't back off the cross slide, just run off the end, turn around and run back on. You also need to wiggle that until you find a minimum on your indicator. Other than that, centering up rectangular stock like this isn't too much harder than doing square or circular stock. That's my block with spigot. You saw me setting up to do that. I didn't bother showing you turning that down because that's pretty simple. Similarly, I didn't show myself drilling the hole in the end there because that's pretty simple. That's 5.5. I'm going to bring that out to 6 so it's a nice fit. And this bit of material here is going to be trimmed off. This is just excess. I put it there to I had something to hang on to, and it was just the size of this bit of scrap that I was using for this. So to do that, I actually got my 1, 2, 3 block out, or one of them, put that in there, and then used that as a base to scribe that. And that means that it doesn't matter whether this deviates slightly and it's 0.1, 0.2 millimeter out. I'm measuring from this face here. So I've centre marked couple of holes there. I'm going to drill those, and then I'm going to put a dowel in them, something I've always wanted to try, and I don't think I've ever done it, but use that to put a radius on that corner there using a vise in the mill. This build has lots of little pieces in it. This is probably one of the more complicated ones, and not so much because it's got any tricky machining to it, it's just that it's got a lot of stuff on it. This started off as a block of material. I took out this piece, and then the two sides here, those bits. And then it was a matter of putting in the half cotter there to hold the dial indicator, and then the rest of the holes, and finally putting the radii on the corners there. The indicator I'm going to use is a compact one, and I do have a Metatoyo one as well, but that has to go in like that. Okay, and then that should be better. And then there's another little piece, this one, which comes on and needs to hit on that. And so that's the basis of what I'm doing here. The machining continues. I'm just showing you this because I now want to do the sides here. And I've got the situation where I've got a step there, and if I just try to knock that down onto the parallels, it's not going to be very easy. And so I thought I'd just show you this one. This is just a block of steel of some sort. I think it's a bit of stainless, but it doesn't matter. But what I'm doing is I'm just using that as a spacer to knock that down. And so if you ever got that situation where you've got a small step or a small part, you can't quite get in there, by all means get yourself a block of something and use that to put it down onto your parallels. I'm about to start drilling my vertical holes through these surfaces, but before I did that, I drilled a flat bottom hole halfway through, and I've got a brass bush in there, and that's for a cotter to hold the indicator stem. So I'm now going to mount that up, and I'll use that as a convenient sort of step, and then drill my hole through there, and there's a third one there for a little dowel pin. This is where I am now. I've got my two legs and I've got a clevis on the back there. Looking at that, I'm not quite sure whether that's going to be strong enough. I may have to take that off at some stage and make something better, but it is what it is for the moment, and certainly it's good enough to try out. I've got a block on the back there which that'll pivot on, like so. And then, and I haven't got any holes drilled there or anywhere else in here. That's coming up. I've got here the most complicated thing that I've done for quite some time, and that's the block that holds the indicator, and it also pivots. So I've got a couple of brackets there, and these were, you know, these could be machined, but these were welded up just because that's what I was doing at the time, and I thought that's a good idea. That sits in there, lines up with the pins, so, and the pins I've still got to put in here, by the way. Right, I've got a little doozer flicky here on the end to push the end of the indicator. That's the clamp for the indicator, and then there's a spring in there. And the way this is going to work is once I've made up that central rod, that'll get screwed onto here, and as I wind a nut on the back here out, these things will spread out. As soon as it encounters any resistance, these will stop, but winding on the nut will cause the shaft that goes through the middle to pull up, and that'll hit the indicator end and so give me an indicator reading. And so it's going to work the same way as the IRA 2A, in that I'll get the needle coming up to, you know, whatever I designate as the appropriate spot, and I'll know that if I then come along, take that out of the hole, come along and measure across the pins with some with a micrometer and get it so it zeroes in the same spot, I should have the same reading. Who knows? Anyway, I've run out of daylight so far, so thanks for watching, and fingers crossed continue with this next week.